delta guy was the delta table, the change in the table. You guys have seen pi, obviously, 3.14196, et cetera, et cetera.
Is that a letter?
Pi? Mm-hmm. He's right. Where is he? He's right before. There we go. He's right after psi omicron. And you have phi chi psi. Phi chi? Oh, Steve. No, I think it was. Oh, how do you say ch? It's not chi. Although good try though. I think it was chi, right? Phi chi psi.
I love chai tea.
I like boba.
Oh, man.
I love boba.
Oh, it's chi, right? Chi. Anyway, phi chi psi.
No.
When Jesus said he's the Alpha and Omega in Revelation.
Beginning and the end.
Mm-hmm.
Oh my god.
The beginning and the end of the Greek alphabet.
Oh, I'm the end. Wait,
Beginning and end, the first.
I think I'm the jot in the tail.
John.
Wait, so if you say pi over sigma, that's a word?
Move.
Pi over sigma, is it a word?
No.
How is the
I don't
KSI?
think division is really like a way of writing words in Greek.
No, I mean pi over sigma.
Oh. Sigma is something that you guys might see on like the PSAT or the SAT or the ACT because sigma has to do with summations. But there are other things in math besides like, oh, hey, there's an extra meaning. There are things like gamma rays, right?
Yeah.
Or there are lambdas that are used in a lot of like physics equations. In like future deeper sciences, they're going to see some of these show up as well. Omega is used from time to time. Mu is used from time to time. Some of them are kind of confusing, so we don't use them as much. So like nu would be a little bit harder with it. Like, is it a V? Is it a nu? I don't know. Delta is used a lot. Alpha, beta, gamma, delta. Epsilon, not so much epsilon, but sigma for sure, pi for sure. But the big one for us is technically theta. Now, in geometry, didn't we talk about how capital letters were angles and lowercase letters were sides? Is that still kind of a thing? Yeah, it's still kind of a thing. But as you get a little bit deeper in math, we also start using Greek letters
Feels like a fork.
Wait, do
to
I have to
signify
learn this?
angles. Only the highlighted ones. But I want you to write down the whole Greek alphabet. It's okay, you can take out one of those songs and just have fun with it. You have a new alphabet song, but not because it's new our alphabet song, but a new Greek alphabet song. There you go. All the silly trending things. Psi looks kind of fun, / not fun at all. But anyway, no, I am not preparing you for sororities, I'm preparing you for math instead.
I didn't hear before. I think you guys were ready before.
2 and 1. Oh.
Preparing you not to sound stupid later. There you go.
I don't think you can stop us.
I'm preparing you to not sound stupid. I'm not saying I'm stopping you. If God doesn't even stop us, then I don't know if it's my job necessarily to stop you. But I can warn you.
I don't think any.
Well,
I think we're just too stupid.
No, just me.
there you go.
You're not wrong.
Roasting. Hey guys, why is one black and one red? Any ideas? Maybe it was way
Or
back here.
diversity.
No.
Because
One is negative.
No. Anybody ever done any like finance or like have any parents that do any sort of
red's
bookkeeping or any sort of
Red's
like keeping
bad.
of accounts?
Yeah.
That's what we call Black
Have you ever
Friday.
heard of
because
staying
thumbs
in the
are
black
up and red.
or going in the red?
One pair.
Right? If you're in the black, Black Friday is to try to have their account books go in the black before the end of the fiscal year. Because it's like, let's get all the money in before our accounts are all done for the past year. Going in the black means you have a positive amount, and going in the red means you have a negative amount, like you owe more than you have, or you have more than you owe. Anyway, as far as keeping accounts. So anyway, why did I use black and red? Well, okay, if you're going counterclockwise, counterclockwise, that's going to be a positive theta measure, a positive angle measure. Going counterclockwise is a negative theta measure. You guys have seen angles before. I'm not worried about that, but I don't believe you have a full mastery of them. So we're going to be working on angles before we even get to trig. Guys, look at the section. Does it say trig? No. What does it say?
Radians.
Do you know radians versus degrees, degrees versus radians?
No.
I didn't memorize it.
Okay.
Remember
So,
the pop
a
quiz?
few things about a standard position. Thank you. Standard position. Yes, Mr. J just kind of gave you a blank circle and said fill in, right?
Yep.
I say you need to understand it in, out, up, down, backwards, forward. So, filling in the circle is not the point. Could it be helpful? Yes. Could it be detrimental to your deeper understanding in pre-calc? Yes. You're going to have unit circle quizzes, but not like that. Not a simple fill in. Come back.
No.
Come back.
So easy. I should have seen.
Don't worry. We'll have done quizzes. Okay. Vertex at the origin. Dum-dum for not being a dum-dum. Vertex at the origin.
We should have done those.
Standard. I know, dum-dum.
I'm the
Not today though. Vertices of standard position, it's always put at the vertex. What vertex? Well, in physics, it's kind of like that XY can be drawn a million different places in a certain picture. But for some sort of XY axis, the vertex is where we start measuring angles from. That's the origin. Positive rotation is a counterclockwise rotation, starting at the positive x-axis, going either up or down. And then the Greek alphabet. Okay. Let's move on. Radians. What are they?
Numbers.
Units, technically. Right? Radians. They're units. Oh, like inches and feet. Yeah, kind of. Sort of.
Moles.
Question. How is, as you're going to start writing, how is an inch different than a foot?
Inches smaller.
So we're centimeters and meters and
They're all part of one system.
millimeters. And
Inches and feet are in one system.
okay,
Millimeters are out of
inches and feet are in a certain category of measurement that centimeters and millimeters and all those other meters are different, right? We have the English and then we have the metric. True. I'll talk about America and the rest of the world right now.
Yay.
Yeah.
Love America.
Coming back though, coming back. I didn't hear it.
Speak English.
I can whisper a little bit louder so you can catch on. Inches and feet. Okay. I want you to think of a millimeter. Ready? I want you to think of a millimeter. Super tiny, true little tick mark on a ruler. A meter stick, I guess you could say. Or the metric side of a ruler. I want you to think of a millimeter. And then I want you to think of, I should probably say the same metric system, but I don't want to the same measurement system. No, it doesn't matter. A millimeter and a yard. Millimeter and a foot. Okay? I want you to think of a millimeter versus a foot. Which one's smaller?
Millimeter.
Yeah, it is. Which one's bigger?
Foot.
Wait.
Why would we ever want millimeters?
When you're writing small stuff.
I'm 6 feet. I would never want to know what I am in millimeters. What's the point of millimeters then?
For small stuff like me.
For small stuff like you. Or even smaller stuff, right?
Okay.
For smaller stuff. You've been in a science class. Is there a purpose for millimeters? Yes.
The aluminum foil.
Give me back. There's a purpose for millimeters. True?
Yeah.
But there's also a purpose for feet. True?
Does it say S equals 1?
I want you to think of, in just a silly example, I'm going to even write it in like yellow that, to be honest, if you looked it up on a computer screen, you probably wouldn't even see it. You can see it here because the projection is kind of lame, to say the least. But we can say that radians kind of are to feet, and degrees are kind of to millimeters. Now I'm going to erase this in just a second. I just want you guys to kind of be thinking of that. Radians are kind of like to feet, and degrees are kind of like to millimeters. Because if you guys look down here in this circle, now I know there are formulas, we're going to zoom in if you can't see it. It's no big deal, you're just setting it up for right now. But without me necessarily showing you why, I just want you to have some understanding of what you're doing when you say pi over 6, or pi over 4, or pi over 2, or 2 pi, or 4 pi, or 6 pi, or even just pi in general. They are all radian measures. Now they're numbers that don't necessarily mean anything, but in math we typically assign them to angle measures. And I want you to think of what you're actually doing. So down here, do you guys see the circle? That's kind of been split up into 1, 2, 3-ish, 4-ish, 5-ish, 6-ish pieces. That's awkward. 6-ish pieces. It seems like there's 1, 2, 3, 4, 5, 6 of these and a little bit more. And to get halfway, there's 3 of these and a little bit more. To be specific, to get a half circle, it's 3.141596, and get all the way at 6.28, blah, 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 blah. But, guys, how many degrees does this 1 radian seem to be? Ish. 1 radian. This entire angle is 1 radian. How many degrees is that? 60-ish? Sure. 2 would be 120-ish, and 3-ish would be 180-ish. Wait, it's a little bit shy. Okay, so this is a little bit lower than 60, a little bit lower than 120, a little bit lower than 180. But does 1 radian seem to be about 60-ish degrees? Yeah. So 60 little baby tick marks, if we were to show the degrees like millimeters, 60 little tick marks to be 1 radian. So radian's just like a bigger unit of measure, and as we just talked about, would you want to measure me? Would I want to measure me in millimeters? No. No, thank you. Feet? Yeah, that's a pretty good one. 6.2. That's good. Not 6.2. 6. Oh, that's awesome. 1666666. Anyway. Measuring in feet sometimes makes sense, and measuring in millimeters sometimes makes sense. Measuring in radians sometimes makes more sense than measuring in degrees. Okay? But which one, let's just be honest, are we more familiar with? Degrees. Yeah, if I say, hey, what would an angle that's like, I don't know, 4.27 look like? You're like, 4.27 degrees, right? No, just 4.27. Well, if it's not degrees, then what must it be? I don't know what 4.27 is. But if I was to say something to the effect of, 250 degrees, would you be able to find that?
Yeah.
Why? Because you're used to it.
Yeah.
You've learned for a long time now that how many degrees is in the corner of your page if your page is nice and at a right angle? 90, right? And that makes that 180, and that makes that 30 and 45 and 60. For some reason, degrees make more sense. But here's the hard part. Degrees are much less natural. Degrees are like a man-made construct. It's like, we don't like the radians, so we'll talk about things in terms of degrees. But to be honest, it's not as helpful because, what is a radian? Here we go. Ready? Because, what is a radian? You realize radian is the bigger unit of measure, right? A radian has to do with arc length. Okay? So over here, angle measure derived from, we're going to go to the formula in just a second, but it has to deal with arc length. If you guys realize when you were looking here, when it said 1 radian, do you see how there was 1 R? 2 radians, there were 2 R's. 3 radians, there were 3 R's. 4 radians, there were 4 R's. 5 R's, 6 R's. Wait, what's R with a circle? Radius. Oh, radians are really just little tick marks of radiuses? Check it. If you were to make a ruler, and if you were to make the units, Alec, a ruler, and on the ruler you had the radius, and you marked 1 radii, or 1 radius, 2 radii, 3 radii, 4 radii. If you were to mark and make a ruler of the radius, that's what a radian is. And then you would just wrap it around the circle. So imagine, is there such a thing as a flexible ruler? Yeah, it's called like a measuring tape if they're taking like your sizes for like a suit or a dress or something else. Or like just a ruler that you play with and never break.
Those are the ones that all the kids had in elementary school.
The ruler shaped like circles, the half circles.
You were the cool one if you had that.
Yeah.
Were you thinking the protractor?
No, not a protractor. It was a plastic ruler. But it
Oh,
was like shaped
there
like
you
a half
go.
circle.
Okay, we can use the wristband idea. I was thinking more of a measuring tape. But anyway, long story short, let's think of a ruler that could go around a circle. If you could figure out what that circle's radius is, which usually we're totally used to figuring out this as being the radius, right? But if you take that, you take this flexible whatever, string or flexible wristband, and if you mark off 1 and 2 and 3 and 4 and wrap it around, guess where one of those would get you? Right here. Guess where 2 of those would get you? Right here. Guess where 3 of those would get you? Right here. And so, Alec, how many would it take to get perfectly over to 180 degrees, a perfect half circle?
So 4. Wait, no.
No, 4's down there.
So it's like 3.1.
4, 1, 5, 9,
Oh.
6.
He said
Because
one.
pi. It takes pi radians, pi radii. Pi radiuses measured around a circle to get there. So, this formula says, if I'm trying to get an angle, now here's the struggle, ready? If I'm trying to get an angle in radians, all I have to do is figure out the ratio, oh yeah, it's a fraction, of the arc length to the radius. I can measure an arc length, and when I measure an arc length, like if I'm talking about a certain angle or a certain portion that has some sort of rotation to it, if I could measure that arc length and how far that arc is, and then I just divide by the radius, I can have an angle measure. Whereas in degrees, I would take like an aerial photo of it, and then I would kind of like project this whole like 360-degree protractor thing on there and then count. That's awkward, that's annoying, that's not helpful. But I can actually measure like arc length, like distance around, and I can figure out a radius measure from the center of whatever object I'm talking about. And then if I just divide, I have a way of describing that angle that's very natural, as opposed to, I like protractors better, tick, 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 very man-made. Yeah.
When we're talking about arcs and arc lengths, is it connected in any way with like electrical engineering, with working with arcs and stuff like that? No, I believe.
Off the top of my head, I would say yes, but in an abstract way. But I don't think I have a deep enough knowledge. I would say, why don't you go peek at it and see? Let me know what you find out, because I'd be interested. Yeah.
So the pi is the amount of degrees that it would take to get 3 radians to 1 radian.
To get for 3 around half of that.
So that's the pi is the measurement of the tiny space.
Pi is the measurement of how many radii to get all the way over the length, the distance. Does that make sense? Pi is how many radians. Which, guys, I mean, a radius could be measured in miles or inches or feet or who knows what, and it could have a number other than 1, but we could just say, like, okay, the radius is 12 inches. Okay, sweet. So 12 inches is 1 radian and 1 foot, but 1 radian. And I can use that as 1 and 2 and 3 and 4. In my example, it'd be feet. But let's say that the radius was 3 inches. Well, this would be 1 3 inches measured around, 2 3 inches, 3 3 inches, pi 3 inches would get us halfway. 2 pi 3 inches would get us all. Okay. So what is pi? Well, technically, isn't pi just a Greek letter?
Yeah.
In context, yeah. If I opened up my dad's Greek New Testament, and if I was to be like, oh, hey, there's a pi.
Are you Korean?
It didn't, no, I'm not, but my dad took one of those theology. He was in seminary. But if I opened up my dad's Greek New Testament, like, there would be tons of pi's. Why?
Because
Would it mean angles? No, but it would be like in context, it would mean a letter, and it would mean like put them together with different letters, make words and make meanings. Okay, so pi could mean that, but in context in math, right? Context is important. Pi is always referring to some sort of mathematical quantity of 3.1415926, this special irrational number that seems to be exhibited in nature in many different ways, but one of the key ways is in circular objects. In circular objects, because pi.
Yeah.
pi goes to infinity, just like infinity. I was about to say that thing.
I don't want to show this equation. For some reason, I just want
That makes no sense. Because if you create any number, doesn't never already be a resource. Exactly, that's a number. Because numbers are idiots. He found a number that worked with what he wanted it to do. Guys, ready? Numbers are man.
Yeah.
Numbers are.
Everyone still both said that.
Okay.
Make sense out of
What?
We're going to discover what pi is using the circumference formula. Let's go there. Circumference. Circumference of a circle is the distance, what, in or around? Around, right? The perimeter of a circle. And so circumference, the perimeter of a circle, you have been taught for a long time now that circumference is either 2 pi r or pi d. But question, who are we looking at in context of this question? who is or what is pi. We could technically use either one, but in context of what we just saw with radians, I think the one with radius might be a little bit easier. So if we were to go ahead and say, okay, circumference is the distance around an entire circle, right? Circumference is the distance around the entire circle. Question, where could I plug 2 pi r into that equation that we just saw a second ago? Where could circumference go? What is circumference a measurement of? Is it an angle, is it an arc length, or is it a radius? Yeah, because circumference is distance around. Arc length is distance around the arc of an angle. So I could go ahead and take that formula and say, okay, so theta is equal to, and I could have that formula, and then I could take my circumference and say, hey, you're an example of an arc length, and the arc length of an entire circle. Wait a minute, what happens if I plug in the arc length of the entire circle? What happens to my arc? Circumference is dependent on radius, and this angle in radians is dependent on radius. So I just showed with a very simple illustration that who is pi or what is pi? Well, the distance around or the arc length of an entire circle, right? The circumference goes all the way around. The radian measure of an entire circle is 2 pi. If the radian measure of an entire circle is 2 pi, then what can we say about pi itself? What part of the circle is it? Half the circle. I could say then pi must be half of the circle. Specifically the arc length of half of the circle, or the angle that encapsulates half of the circle. Now, I know this was all built on a formula. I'm coming to you, Priyanka. I know this was all built on a formula that you guys memorized. It's a mathematical fact, so I didn't tell you where that formula specifically came from.
That's okay.
But built on this fact, we can see why, in our unit circle, for instance, it took 2 pi to get all the way around. If circumference is truly 2 pi r, well then, the angle radian measure of an entire circle is 2 pi. The angle radian measure of half a circle would be just 1 pi. Priyanka, go ahead.
So 2 pi r, what is the A equation is S over R. What is S?
S is arc length. So it's how far, if I were to take any circular object, and this one's hard because he swishes, but that's okay. If I was to take, for instance, this cylindrical roll of paper towels, yeah? And if I was able to, which I probably could somewhat do, be a little bit messy, but I could put like a stick directly across, a stick directly like horizontal, vertical. I would know the center of my circle by having those two intersect, right? Where they intersect is the circle. I could have a skewer come all the way up. That center would be the center of my circle, right? As far as the surface. I could measure my radius to figure out how far that is, right? Awkward. And when we measure that radius from the center to the outer edge of my cylinder, my paper towels, then, you asked me what arc length is. If I were to take that measurement, whatever it is, and then get some flexible ruler, but flip it on the back so none of the units are shown, get a Sharpie and then mark off 1 of those, 2 of those, 3 of those. So not inches, not feet, not millimeters, but those little radii are my 1 and 2 and 3 units. And then if I was to wrap that around, it would take 6.28 to get all the way around and take approximately 3.14 to go out. The arc length is measuring the outside of the circle.
Okay.
Does that make sense? And radians say, well, if I measure 1 of those radiuses, if I measure 1 of those, measure it around, that's 1, that's 2, that's 3, as far as 1 radian, 2 radians.
So how can circumference be both 2 pi r and just 2 pi?
Well, that's the hard part. Circumference is saying the distance around based on some sort of inch or foot or centimeter, or it's based on the units that we know. Whereas radians say, no, just how many radiuses. So in my example, we were making for radians, for 2 pi, that's it. I was saying you have to take this radius and make it the units of measurement on your ruler. 1 radius, 2 radius, 3 radius. This one says, oh, the radius is 3.4 inches. Cool. There's 2 pi of those 3.4 inches to tell you how many inches that would be. So if I was to flip the ruler on the other side, how many inches would add up to be there? Does that make sense? So on one side of the ruler, it's just measuring with how many radii, 2 pi. On the other side of the ruler, actually I have the tick marks and I know how many inches it is. Circumference tells us the inches. Radians just tell us how many radians. Kind of. Okay. So, what are all these special angles that you guys theoretically were supposed to memorize last year? Pi over 6, pi over 4, pi over 3, pi over 2, pi, 2 pi, and oh wait, weren't there way more? Couldn't you have kept going? And couldn't you have said, not only is that 1 pi over 6, but this is 1 pi over 6 away from pi? So it's 6 over 6, take away 1. Or couldn't you have said there's 1 pi over 4, so there's, well, that's 1/4. That's 1/2. Couldn't you say this one's 3 pi over 4? Because you're taking 1 pi over 4 away. Couldn't you say this one is 2 pi over 3? Because you're taking 1 pi over 3 away. And I might be like, wait, taking away? What are you talking about? Well, guys, aren't these measured in sixths? You've taken the half circle and cut it into sixths. So how many slices are there? Well, there's 6 of them. If I had the whole half circle, I would have 6, and I took away 1. That's 5. This one, I have 4 pieces, so that's 4 pi over 4, and I take away 1 of those. Oh, that's 3. This one, I have 3 pieces. I take away 1. Oh, that's 2. So check it. Can't we go the other way too? What would this be? 7. You're just counting.
So much.
That's big brain.
Wait, so why do you go from this guy to that guy to that guy? Why not just keep going? What would happen if we went again? 8 pi over 6. Oh, wait. Doesn't 8 pi over 6 reduce to be
Oh my goodness.
4 pi over 3?
Massive brain.
Precalc. And algebra 2 is kind of like,
But if
let's
you
just
did
memorize.
the same thing. I think he tried.
Wait, where's this dude? I didn't get the over 4 one. It's because it's a totally different angle measure. Fourths and sixths and thirds. 2 sixths makes 1/3, right? 1/6, 2 sixths, 1/3. 3 sixths, 1/2. 4 sixths, 2/3. 5 sixths, 6 sixths, 7 sixths, 8 sixths, 9 sixths, 10 sixths. Okay, we can keep on going. Long story short, the sixths and the thirds are just all the double sixths. I know it's weird, but the thirds are just all the double sixths. The fourths are just this whole separate thing. These are 30 and 60s. Oh yeah, 2 30s makes a 60. He's a 45. He's a different angle measure. But guys, just keep counting. So where would this 45 get me? 5 pi over 4. Where would this 45 get me?
6 pi over 2.
But what's 6 pi over 4? Isn't that 3 pi over 2? 6 over 4? Oh yeah, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Oh, it's a thing. It's just fractions. That's all the unit circle is. It's just fractions. But wait, check it. So, hold on. If I can just count by thirds, I don't need to get him. Instead, I just need to think of there's 1/6, there's take away 1/6, add 1/6. Ooh, who would this guy be? Because, wouldn't this be 12 pi over 6? Take away 1? Oh, of course, he's 12, take away 1. That's easy. Who would this guy be then? Wouldn't he be 8 pi over 4, take away 1?
7 pi over 4.
Who would this guy be? Wouldn't he be 6 pi over 3, take away 1? Yeah, the whole unit circle, guys. Well, the angle measures. Haven't done so good but the angle measures. Because it's 1 pi over 6, 1 pi over 4, 1 pi over 3, and then start doubling them. Well, doubling them gets hard because then you start running into these whole like pi over 2s. You have to reduce things. So I just kind of go up 1, back 1, forward 1, back 1. Up 1, back 1, forward 1, back 1, up 1, back 1, forward 1, back 1. Works for me. We'll see if it works for you. Calculus has to remember geometry.
Oh.
So they had to use volume of a cylinder is pi r squared h, but do you guys see how there's this weird dv dt, something, 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 something? Yeah. Okay, good. Co-terminal angles. Co means with or together, doesn't it?
Where's my homework is?
She's already on. She was here for just 2 years and she already
That was second.
that was very
A share a terminal. Hey, does this make sense? If co means with or together and it's co-terminal, doesn't that mean that they're going to end in the same place? And how do we end in the same place? Co-terminal angles, which we could call, I don't know, some sort of alpha. You use Greek letters to talk about angles, that's cool. Is going to equal some sort of theta, some beginning angle, plus some sort of multiple of 2 pi. But it has to be whole multiples of 2 pi, like a whole rotation to get back to it, or a whole negative rotation. So all of those ends are going to be like positive and negative counting numbers, which are called integers. Integers are positive and negative whole numbers. If I can go clockwise, which is negative, a whole 2 pi, or counterclockwise, which is positive, a whole 2 pi. Or I can go counterclockwise 4 pi, or clockwise 4 pi, etc., etc., etc. Now, guys, some of you are asking about homework. I know. Let's peek and peek and peek. Oh, do we still have a couple things to learn tomorrow? Yeah, so this is a 2-day section, but that's okay. You guys are going to have me for not much time at all. Tomorrow? So here's what I'm going to do. Do you have homework specifically to do tonight? No. And since we're barely going to have class tomorrow, I'm going to post the second day video of this section tonight for homework. Watch it, take notes on it, and your homework for the weekend is done. Sound good?
That's the homework?
Awesome. Yep. The book work won't be due until Monday, but we're not here. Well, you are long enough for me to say, hope you watched the video. Try homework for Monday. Sound good? Okay. Bye, guys. I'll post the link in your Google Classroom. See you later. Welcome.